In last tutorial, we have learned the concept of function with the help of relation. But remember that now you are entering into the real world of functions where there are a lot of different functions, among which some number of functions are very important for class 11 students. But each of the function contains a common statement that f is a function from a to b defined by y is equal to fx. If you do not understand the full meaning of that, then it will be difficult to analyze the domain, range, and functions of those functions. Let us understand x is the input variable, which is actually the x coordinate, and f is a function name or the type. Okay, and this x is an expression format in x depending on f. For example, x cube plus 1 under root 9 minus x square. Okay, so if you call this f1 of x, then you may denote this as f2 of x. Okay, but in general f1, f2, f3, etc. are taken as the variable f. Okay, and this y is obviously output variable, which is actually y coordinate. You have to remember. Okay, and xy geometrically represent the points in xy plane, which is known as the graph of y is equal to fx. We are now going to understand that f is a function from a to b. In earlier tutorial, you have seen very easy definition that a relation is said to be a function if the input set completely the domain of the relation. Okay, but here it may or may not be. This is the fact we have to understand here with the help of an example. Fx is equal to x cubed by x minus 1, where x belongs to the set of real numbers. So what you are finding here, all x you can take no problem except x is equal to 1. So you see that domain is equal to, we can write the set of real numbers minus this element 1. So df is a subset of R, you can say. Okay, so instead of this, if it is defined like that, f is function from R to R, then we see that total set R is not the domain by this format situation. It is a subset only. Okay, I hope your concept has been clarified. Okay, and in future for any function you have to check this type of things depending on the format that I have shown here. Also two formats and different other formats are there that will bound us to check that one. So now we are going to take functions classifications. Still these things are also under the functions basics. One is depending on the DF and RF values, means domain and range. And another classification is based on the function formats. Okay, so I'm taking first this thing. For real functions, the essential condition is DF is a subset of the real number set R, and similarly range is also a subset of R. Very essential condition. If we find these two things in a function, then we say that the function is a real function. Okay, so better to understand with the help of an example. Supposing that fx is equal to x square is a function and where the input variable comes from the set of real numbers. Obviously, it is seen that anything x you take, 0, plus, minus, fraction, integers, you will get some corresponding real numbers. So obviously, it is understood that df is a subset of R or equal to R. Anyway, then we are getting range is also a subset of R. So these functions will be called a real function. Okay. Now let us understand that real valued functions. In the definition only shows that this must be the condition in a real valued function. So let us take an example again, this one. Fx is equal to x square, where x is constant to the subset. Okay, 3 is a real number, iota is an imaginary number whose value is root over minus 1. Let us see by putting those things what we are getting the range. Okay, f of 3 is equal to 3 square equal to 9. Now you put this one, f of iota equal to iota square equal to root over minus 1 whole square equal to minus 1. You will get the details of iota. This is an imaginary number in the chapter 4, okay, complex numbers. Now you understand definitely like that. Corresponding to these 3 and iota, our f is equal to 9 and minus 1, 2 element, okay. Thus df is a subset of complex number, okay, and rf is a subset of real number, okay. So one more conclusion, that all real functions are real valued functions, but all real valued functions may not be the real functions, okay. So we are taking the classification, entering into the classification now, all of which will be under the real functions. These are the most important functions. Next day we shall start explaining all those functions definitions and their corresponding domain, range and graphs, which are very important for you. Thanks for watching.